It's my pleasure to introduce the Getting Ready to Teach Modular International IGCSE Physics. Whew, what a mouthful. We've got quite a lot to do, quite a lot to get through, and it's a 3-hour Zoom meeting. So I will give people a break partway through so we can have a little bit of refreshment, get your coffee or other drink, and also I will give people at specific times opportunities to ask questions, because if you ask questions all the way through, then I'm going to get distracted and I'm not going to get everything done. So what I'm going to do is say, oh, here, if you've got any queries, we'll try and deal with them at this point, which is why you haven't got your mics on. If we need it, Leon will put them on for us. So let's get started. Okay, if I can. Oh, it's quite hard to get this to do too sensitive. We're going to try and focus on planning, how to teach a course, how to understand the assessment. If you don't understand the assessment, it makes it harder for you to teach. We're going to have a look at Pearson mark schemes and have a look at the support that's available, which is quite large. Okay. Quick query. Has anybody actually been teaching modular at all? If you could just say yes in the chat or no in the chat, please. Oh, we have got some yeses, which is nice. Quite a few yeses. And a few no, but mostly yeses. Some no's. That's good. So I've got a mixed bunch, right? We were really, really, really pleased to be able to offer modular. It's something that we've wanted to do for some time, but because the IGCSE is loosely tied to the home GCSE, and some of our home centres can take IGCSE, we were stuck with the rules and regulations, and they've eased them, which now means we can have modular. Home GCSEs cannot have modular at all. So we were really pleased to introduce it because it seemed to fit better into our okay, I'm getting a message about the voice from the speaker. Is that a single person, or is it, or do I have to speak up a bit? Okay. So what is the most important thing you want to take away from this morning's session and this afternoon's session for most of you? Do you want a general introduction? Do you want specific queries? Do you want to know about the marking? Planning. Marking. General. All of these. Okay. Any more? Marking. Exam structure. Yeah. Hopefully. That's good. We've got quite a few bits and bobs here that we can get through. And yes, all of these are planned. I am going to talk about marking and exam structure. So let me try and introduce myself. Obviously, you're with Pearson. Pearson has got, this astonished me, that we actually mark more than 10 million scripts a year, right? Which is, it's an amazing amount. And then we operate. Okay, let me talk, before I go into the specification overview, let me give you an introduction to me. My name, as you heard, is Pauline Anderson. I have been marking with Pearson since 1988. I started as an ordinary examiner and worked my way up, became a team leader, became a reviser. I became a principal examiner and then chief examiner. And as chief examiner and principal examiner, I wrote the exam papers, as well as leading the team of people and marking. Then I got bored. I suppose that's really. I got to the point where I'm thinking, can I think of any more questions? And the answer to that was no. And very nicely, as soon as I stopped being able to write the questions, or I then got the job of reviser. Oh, sorry, not reviser, trainer. So I now travel, and I noticed that one of the delegates here is from Bangladesh, and I was actually in Bangladesh last weekend. And later on this month, I'm going to Spain and then Cyprus and then bouncing around the Middle East. So I really enjoy the job of trainer. So I've done all the jobs that possibly could be done. So I hope I can give you a good insight, A, to how the exams are structured, B, why we're structured that way, C, how we get the how we do the marking, and give you some hints about where to find extra support. Right, let's have a look. What is in Modular? Right, Modular has the same content as we had with linear. It's just that we're going to assess it in a slightly different way. So we're still going to have 2 exam papers. The questions are going to be the same type of questions. They're written in the same manner. So we'll have multiple choice structured, some data questions, some calculations. We are going to be very, very clear about what is in each paper. So I'm going to have a look at these, the content structure. We are going to actually, we've taken the linear and we split it into chunk 1 and chunk 2. Right? And then we're going to test these. All of our assessments in GCSE and in fact in IAL, whether it's biology or chemistry or physics, have the same what we call assessment objectives. So we have recall, we have application, and we have analysis and evaluation. Right? And I will have a look at the, excuse me, I will give you an example of how many marks in each shortly. Our specification also gives you a long list of our command words, right? In other words, these are the instruction words for every single question on every single exam paper, right? So there are words like describe, explain, evaluate, state, give, right? They are consistent in biology, in chemistry, in physics, and GCSE and IAL. So we use the same words and they mean the same thing in all of those subjects, right? We're also going to include mathematical skills. I'll talk about those later. We have about at least 30 marks, 30% of our marks in physics are maths, which is what you'd expect. We try to make sure it doesn't go above 40% now, right? We will also have practical skills, which are anything from saying things like which variables are controlled, which is the how will you present this data, can you draw a line of best fit? All of these are in practical skills. Transferable skills are the ones we put in at the back. So sometimes a kid says, I don't want to do physics because I'm not going to do physics at an A level. And they think, why should I do it? Well, in actual fact, a lot of the transferable skills are the ones you should point them to. We're teaching you how to analyze. We're teaching you how to reason in a logical way. We're teaching you how to communicate. So these are our skills that you can actually push to the kids and say, it's not just physics. We're teaching you lots of other things as well. Right. So most people, already know that you can find the specification on the website. So if you look at the top of the website and go and have a look, our qualifications, international, GCSEs, physics, modular. You can download the specification from there. And you can also have a look at the side where it says course materials. We've only got a couple of sample assessment materials, mostly because we didn't have our usual 2-year run-up. We had only a 1-year run-up before this was available. We have got exam materials now for each of the exam papers, which was sat in June. We have now got the exam paper, the mark scheme, and the report to centre, which is written by the written by the principal examiner. There's a lot of teaching and learning materials. Now, I believe, and I'll show you a slide right at the end, that Tim Lawrence has actually moved into a new position, but his email stays the same, and we've now got a new person who's looking after international science called Jonathan Wong, and I'll give you his contact details at the end. So all of this material on the website is free, right? So if you also want to have a look, you can find the ordinary 9 to 1 specification and the modular. The content is the same. It's how we split it and how we examine it. I've got all of this material bouncing in as I click my mouse. Right. So let's have a quick look at each of these items. Right. I don't know. I didn't notice that one when I did some of my corrections of this. It should be biology, of course. Qualification. If you want to do double award science, you are going to do 2 papers in biology, 2 papers in chemistry, 2 papers in physics. But the papers that you do are going to be shorter. Right? So GCSE physics is normally paper 1 and paper 2 are both 90 marks. Do both of them and you get your GCSE physics. If you're doing double award, you have to do papers 1, 2, 3, 4, 5, and 6, and they will be shorter. The content will overlap. Right? The content will overlap, and the content of the physics 1 paper, which you can see on the bottom right hand side, and the physics 2 paper on the bottom right hand side, will also overlap with linear, which gives us a comparability. Okay. Right, so they've got some nice information about this bit. I suspect is not necessarily for you, but it might be the sort of thing that you need to take to your head of department, or certainly to the senior management in the school, why you should choose it, what the advantages of linear is. Right, so excuse me. Right, let's have a look. Why would you want to do modular? Now, to my advantage is that if you've got a student who is learning and they're doing the physics or the biology or the chemistry, they have got 2 years, minimum of 2 years material, and then in a linear course, they've got to be tested at the same time. Right? What happens if one of those children is ill partway through? You've still got to make them do the exam at the same time. Right? So if you have a modular approach, right, what you can do is test the work you taught in year 10 at the end of year 10, or in November, year 11. Or even if you start your course in year 9, you can actually test the first paper at any point up to and including the end, right? So the content's the same, it's the approach that's different. Can you do it in one chunk? Do you want to do it in two chunks? Do you want to do it? Suppose you do it in year 10, and the student doesn't do well. You don't have to repeat the whole exam. You can wait. You can do the repeat of just that unit at any point. Right. So, right, you can take the units all together, or you can take them separately. They can take them in May or June, or again in November, right? If you've got a student who is struggling and they want to resit, they can resit as often as they need to, but just the paper they actually found difficult. If that was paper 1 and they want to repeat paper 1 5 times, they can do so. But we will only ever look at the last 2, right? Whenever they're ready, they can cash it in. You can actually swap, if you like, swap their grades, swap all their qualifications in and get that grade, right? Okay. So we are, and I'm going to point this out, we are the only exam board that offers the modular course. Right, so we're not offering a tiered exam. The exam paper is the same standard regardless of whether it's in year 10 or in year 11. Similarly, in the international A level, the standard is the standard, whether it's at the end of year 12 or the end of year 13. Right? The key difference is uniform mark scale. Because students will be taking the exam of a different series, we take their individual marks on one particular exam and convert it into a uniform mark scale. This is then aggregated together when they cash in. This is like what we do in A level and I think any of the other modular subjects. In the linear, we calculate the grades on the raw marks only, because they have to do both exams at the same time. Right? In modular, they can resit individual units as many times as they want to. In linear, if you want to resit, you've got to do them all at the same time. So if you want to resit the exam, you've got to do paper 1 and paper 2. Right? And then in the modular, as soon as they've got all their unit results to the standard they want, they can cash it in. In linear, the grade you get is the grade you get at the end of the exam, working from their raw marks and only their raw marks. Okay, I've said that. So, possible ways of planning this, possible ways of having a look at this. So, September last year was the start of the first year of the course content, right? Some students did Unit 1 and just did Unit 1. We actually were quite surprised that we had something like 1,500 students who also did paper 2, who suddenly converted into, and I think again, it's easier for a number of students. Week 1, you are doing this exam. 2 weeks later, you're doing this exam. The content is totally different. So we're hoping that, again, we will have the same number of students as we did then doing the exam, but we are offering a resit opportunity. Right, your exam officer needs to make these dates for when you can actually get the marks in. Oh, sorry, get your entries in. I think that probably means more to you than it does to me. Okay, so we have had some students who have already got certificates in modular science. So how do you sell this to the students and to the parents? I'm just looking at the side. Can I give an example of receipt for individual units? Yes. If somebody, for example, of the 1,500 students who did the exam in June this year, did both papers, some of them might want to do paper 1 again, some of them might want to do paper 2 again. And they only need to do one of those papers. They only need to do the paper that they want to do. As long as they haven't cashed in, as long as they haven't sort of decided, I want the certificate. But they can do those papers separately. We're not sure how many, obviously, yet, of how many people will be doing the modular resets, but they are available in November. Right, so looking at your students, as far as the students are concerned, I'd hate to be a teenager again. I really would. If you are a 15-year-old and you're told that you can do half of your physics course at the end of year 10 and get paper 1 done and out of the way, then this is actually reducing their mental load. It's going to reduce their stress, right? It allows them to take the exams when they're ready, right? The same as you might do with a driving test or a language proficiency test. And they can do that resit as often as they want to. So they've got more opportunities. For your teachers, the rest of your teachers, the biggest advantage I find is the opportunity at the end of year 10 to look and see an external assessment of your students, which enables you to then target what they don't understand and don't know. Now, you've got that information because Pearson offers Results Plus. With Results Plus, you can actually go in and access to scripts. You can go in and look at the individual questions for each individual student. You can also have a look at how your school did, how the class did. And that enables you to get that information in the middle of the course to enable you to replan the course for your students. As far as parents are concerned, the exam fees at the end of year 11 is a big burden. It's a big lump. And if you can get some of this done early in year 10, then this enables their planning, their financial planning, to be a little bit easier for them, right? But to me, it's this post-exam analysis that is really important. So let's have a look at 4 possible ways of doing it, right? So suppose the school says, no, we're not going to let you do the exams at the end of year 10. You're going to have to do them like everybody else at the end of year 11. This is a linear approach. But because they're doing a modular exam, they will do 2 exam papers. The exam papers will be equally balanced in terms of 50% of the marks, 50% of the marks, not 61% and just under 40%, as is existing in the linear. And if they find one of these difficult, right, they can then do the reset of just that one unit. So it might be unit 1 or it might be unit 2. So the fee for that will obviously be cheaper. This is a route where I think a lot of people will take, and that is route 2, that at the end of year 10, they will take the exam in for Unit 1. And maybe some of them will need a resit, and they can do the resit in November. And then at the end of year 11, they will have a look and they can do Unit 2. So I think Route 2 is very popular, or will be very popular. Especially if you start your course in year 9. Or if you start your course in year 9, you could, for example, put your exam, rather than June, you could put your exam in November. Route 3 is just basically taking a little bit longer and actually doing all of your Unit 1 in November and Unit 2 in June. Again, if somebody needs it, they could do a reset at the end in November of just the unit they needed to do. Now, there's an advantage sometimes to flipping the order and doing Unit 2 first and Unit 1 first. There's nothing to stop you doing it that way round. Okay. So you will get these slides, or you probably have these slides, so you can actually have a look at these in more detail. So this is, if you like, the first step into teaching modular. You teach it in a linear way. You do not change your teaching whatsoever. You don't change the order. You do nothing different, except that when it comes to the exam, you do Unit 1 and Unit 2 very different times, and enables the students to do 50%. And they're only learning, they're only revising 50% of the content at that time. And if they need to, they've got the November to do resets. Many students would like the advantage, because at present what we say to them in linear is, oh, paper 1, you've got to do everything except the bold content. And then paper 2, you have to do everything. And that's a lot to ask. If we can split it into, oh, you're just doing the first 4 topics and you're doing the second 4 topics. Much easier. Much, much easier. Right, so this is Route 2 again, where you could do one of the units at the end of year 10 in the June exam, giving them an opportunity to resit if they need to the second unit at the end of June in year 11. And again, if they need to, you can have the opportunity to do your resets at a different time. Right? So, Route 3, we've got Unit 1, Unit 2, this time doing it in November and in June. And if they need to, the following year, in year 12, doing the resets. The advantage to this one is it gives students a bit more time to prepare, at least for that Unit 1. And that means that they're a little bit older, they're a little bit more mature, right? You've got to think about your individual students. And again, we got clear topics in physics. In chemistry, the topics aren't as clear. The topics are in a spiral. So all of their topics that they've got, they do half of them they do half of each topic in year 10 and the other half of each topic in year 11. This one could be a route for you. It will depend on what you've actually taught in year 7, 8 and 9. Right, let's have a look. What approach? You don't have to change do not have to change your way of teaching physics, right? We're going to have the same content, the same number of marks, the 2 marks are going to be exactly. Paper 1 modular is 90, paper 2 modular is 90, making a total of 180. Paper 1 linear is 110, Paper 2 linear is 70, making a total of 180. Right? So everything you're doing now can still be done. It can all be done in the same order if you wish to, or you can change the order if you want to. There is no reason to teach the specification, topic 1, topic 2, topic 3, topic 4. If you want to, and you're going into year 10, you could start by teaching topic 3 and then go back to teaching topic 1. We're not actually insisting that you teach it in the order of the specification. How would we know? We only evidence there are 4. I'm going to answer a few questions. Can the resit in June for any unit? Yes. You can resit in June for any unit. You can resit in November for any unit. There are the first 4 topics. The topics are slightly different order. We've taken what was the waves topic, has actually been moved into our paper 2. So they are, yes, I'm saying there are 4 topics, but you don't have to teach them in that order. You can teach them in whatever order you wish to. Some people prefer the textbook order, some people don't. And for that matter, you don't need to change the textbook. The textbook is going to be exactly the same. What we have on the website is the specifications, the sample assessment materials, the getting started, the course planners, the schemes of work. We've got mapping documents. We've got training and recordings of previous past papers, of previous training. We've got mark schemes, past papers, exam wizard, and you can use the linear. It's the same people. The people who are now principal examiner of the modular were team leaders on the linear. The person who is overall the chair of science for modular was in fact and still works as a team leader on the linear. So we've got the same people. It's not a case of this is one group, this is another group, we're doing this. We're meshing the 2 groups together. So the style of the questions is going to be the same. The marking, we mark to the same structure. Right? The big difference is, what are we going to test at different times? So I don't know if anybody has actually, can we do topics from Unit 1 and Unit 2 as your choice? I'm not sure exactly what you mean by that, Anton. You can teach any topics in whatever order you want to. What you are limited to is what is in paper 1 and what is in paper 2. And what is in paper 1 is going to be forces, electricity, energy, and most of the solids, liquids, and gases. So what is in paper 2 is going to be the waves and optics and all that sort of stuff, the electromagnetism, the nuclear physics, and the astrophysics. Now, if you want to teach them in whatever order you want to, and then just say, right, okay, paper 1, this is what we're going to test you on. Paper 2, this is what we're going to test you on. You'll probably find that useful if you were doing what we call a linear approach. Teach whatever order you want to and give them exam papers at the end. Has anybody used Results Plus? Yeah, Anton, yes, you can do all the units in order and so on. Veronica says yes, she's used Results Plus. Anybody else? If you you will need to access this via a code which you get from your exam officer or from Pearson office in the country you're in. It allows you to have a look at the scripts. It allows you to analyze the data that you get. And it allows you to find out, for example, which section did they not do well at? Right? So you can identify the areas that students had a problem with. And then that allows you to target that area when it comes to the reset. Right? Okay. Access to scripts allows you to view your candidates' marked papers, either online or as a download. When I was in Bangladesh, it was useful. People could say, they actually didn't query me very much on the GCSE, but they did on the A level. And they were saying, well, I can see my student did this and they only got so many marks, or can you explain why they didn't get those marks, etc. So it enables you to actually target that. If you have a specific query about a specific student, you can always access via Jonathan Wong. So we are not, because of the regulations in the UK, we are not allowed to have direct contact with our centres and with our teachers. So any query you have for me has to go through Jonathan, and he can pass it on, and it will always go back. That means that they can see that anything I say is clear and above board, and I'm not giving hints about next year's exams. Right? I wish I could. I mean, when I was teaching, yes, I used Results Plus. I also used Exam Wizard, but the Results Plus was really helpful. I had one. There were 4 physics teachers in the school I was in, and we once we started looking at Results Plus, we found that one teacher, his class always did extremely well on the astrophysics, and it wasn't surprising because his first degree was in atomic and astrophysics. So we had another teacher who was an ex-engineer, and his classes did well, always did well on the electricity. This enabled me to go to the head and said, right, I want all of my 4 physics classes timetabled at the same time. And that enabled me, which I had to fight for, admittedly, but we did it. And that enabled me to then rotate the classes around the teachers. So that all 4 of my classes went to my astrophysicist to do the astrophysics, and went to the my engineer to do all the electricity and electromagnetism. Is there a method to create a login? I suspect not, Ushan. I actually suspect not, and because I can't do it. I have to, I do need some data on occasion, and I have to access it through the GCSE teams. So I suspect not. Yes, I do. If you're a tutor, it would be helpful. But I suspect not. They only do it for these schools. So that's the sort of thing you can use with your mid-cycle results. It was very helpful in my case. We went, the marks, the percentage you were getting at the time, it was grade B, grade A, and A star. We went up 10% by doing that, by rotating the classes around the teachers. And targeting the teachers. I don't know what he did. I don't know what this guy did in the astrophysics, because I like teaching astrophysics, but he really got them to understand it, and they did well. Okay, let's have a look at the next one. Talking about resets again, you can reset just the individual units. If you want to reset linear, you can, of course, but you have to reset both. If you, it's just a case of it makes it easier to target which to reset. There's no limit to the number of resets you can do in Modular. We will only take the last two. Is Results Plus available to normal teachers or just exam managers? It should be available to the teachers. The exam manager will be the person to ask for this information. I think it was Veronica. Would you like to share with your example? Because you obviously have used it. Most schools, well, I don't know. In my school, we gave the access initially to the senior teachers, the heads of department, but then I actually found that my technician, who was really computer savvy, could actually do a lot of the work for me. So we gave her access. And we also gave her access to the exam wizard, and she wrote my exams for me as well. It sounds as though I'm being very lazy, but it was actually very good to be able to say my end of topic test was written, I hadn't seen it, so it was really a true exam. I wasn't teaching to it at all. So Veronica says she signed up with the school login. So presumably, once you get a login from the exams manager, you can log in and do your own analysis. And this is, again, a corporate message saying that we are benchmarking it. The certificates you will get will be exactly the same certificates. They will look like that, and it will give you international GCSE, the series, the name, the candidate, school name, etc., and the grade. Right, so they're giving you one example there. Right, so looking at our assessments, they are untiered. Unlike home GCSE, where we have a lower tier and an upper tier, we have one tier. So we are testing from grade 1 to grade 9, right? So the questions all the way through are designed to be accessible. Even in the very last question on the exam paper, there will be something that the weaker students who are loading will still be able to access. There will be at least 1 or 2 marks which are accessible to to people who would normally obtain grades 1, 2, or 3. Right, so we want the full ability range. That has a knock-on effect for the very able students, and they certainly look at some of the beginning questions and they overthink the questions. They look at it and go, this is too easy. And you have to remember, they might be working at levels 9 and 8, but there are some students who are actually genuinely working at levels 1, 2, and 3. Right? So there's going to be no difference in the content. I'm just going to wait and read this through from Veronica. Thank you. I used to print, highlight each student so they individually see their questions to celebrate the top 10 best and the 10 lowest. Then go back, see what happened. Excellent. Thank you. That is a really useful way of using Results Plus. And the fact that you're highlighting the top 10 and the bottom 10 it also is useful for you because you can see where they've got a problem, but it also means that you're celebrating their achievements. One of the principal examiners that is involved in these papers, once a term, he goes in and he sets some homework, gets it back in, and he doesn't mark it in the normal way. He marks it with 3 highlight pens. So if the work is correct, he highlights it in green. If the work is wrong, he highlights it in red. And where there's could be better, the iffy bit, he puts in a yellow. So when the students look at their page, they get back of their notes, they can see that the vast majority of their page is green. And that allows them to think about just the bits in red, just the bits in orange or yellow. So what you're doing there, Veronica, is actually incredibly good practice. Okay, this assessment model. Let's make this point about the practical exam. We haven't got a practical exam. I know that Cambridge International have a separate exam paper, which is practical skills. We don't. The practical skills are assessed throughout. The papers are going to be no different in if you like, in whether one is harder than the other. That is true for the linear, although most students think that paper 2 is harder. It isn't. Paper 1 and paper 2 are equal in terms of demand. The modular has got no crossover or content, right? There's about 2 or 3 tiny little bits which is a crossover, but apart from that, not. And that tiny little bit is actually units, right? It's mostly the units that's not thing. Okay, so unit 1 in modular. Okay, unit 1 in modular has got forces and motion, the electricity section, all the energy resources. So you've got a lot of calculations here with the forces and with the energy. And you're going to have solids, liquids, and gases, the density, the pressure, change of state. Right? Unit 2 is going to be, sorry, yeah, it is 1R40. I misread it for a moment then in my head. So unit 2 is going to have another 1R40. It's 90 marks, so that's 1 mark a minute plus 10 minutes reading time. All right, so that's why it's 1R40. So again, 90 marks, 50%, and we've got the waves. We've got the solids, liquids, and gases, so we've got units again, and basically ideal gas molecules. Right, the electromagnetism and magnetism and induction, as a plea, teach these sections in 2 or 3 different units. Teach maybe magnetism at the beginning of year 10 or at the end of year 10 as or some point. And teach electromagnetism at a different time to teaching induction. We've got radioactivity, we've got particles, and we've got the astrophysics, which is nice. Talking about calculators, you can use a calculator all the time. We are aware that there are a lot of students who do not know how to use standard form on their calculator, and this is a skill that you might want to practice with them. Right? Okay. So the code for these units is slightly different. It's 4W. I have no idea what the W is for. 4WPH1/1P. And paper 2 is 4WPH2/1P. Right? So this is, again, it's a repeat of what we had on the last slide, but in slightly more detail. This is something that you could possibly put up or distribute or give to the students. If it is in bold, it's still in that paper. If it's got a P, it's a practical. So, sorry, if it's in bold and has a P, it's still in that paper. The practicals are as they are in those that content. Right? So they're both obsessed. They're both assessed by Pearson. They're both in November and June. They've both got the same. They've both can use a calculator. They're both worth 90 marks, and they're both 50% of the qualification. The only difference between the papers is the content. The content doesn't overlap, and you can take them at different times. So in the modular, just disregard the fact that there is construction of electromagnets. Apart from if you're teaching double award. If you teach double award, you don't need to do anything which is in bold. Right? On the linear, the non-bold specifications are asked on both papers 1 and 2, and the bold specification can only be asked on paper 2. I'm looking at your query about significant figures. The significant figures, this general rule is work to 1 more SF than we ask you in the question. So if we give you 4 SF in the question, then work to 5 SF. That's particularly helpful when we look at the atomic. I'll look at the astrophysics, and we're looking at changing wavelength due to redshift. If you're working in the ordinary forces of motion, and they give you a question which is gives you a speed of 75 meters per second, for example, then doing your calculations, work to 3 SF, because we've given the part in the question to 2 SF, work to 3 SF. We won't penalize if the student writes 15 places of SF, 30, we won't penalize except if we ask you, and we just once on the paper, we will say, write your answer to 3 SF, write your answer to 4 SF, right? That's the only time we will penalize. But students should be aware of the fact that you keep your calculation on your calculator all the way through, and then round at the end. But we take account of that in the mark scheme when we have a look at the mark scheme. Right. The start of the paper should be easier. We mentioned it. Able students can get a little bit, oh, this is so easy, but train your students to pace themselves. So if you've got able students and they can do it easy, then they shouldn't be spending 1 minute for every mark at the beginning. They might need to spend more time at the end, and that's where they can, if they spend only 20 seconds per mark at the beginning, they've got that much more time at the end, right? Early questions may feel easier. Not all marks are equal, all right, because some of them are targeted at grades 1 to 3, and some of them are targeted at grades 7, 8, and 9. Okay. Now, I've actually asked, I've given you an opportunity to ask questions. Is there any questions at this point before I go on to looking at the content in a bit more detail? Can't see anybody recording, can't see anybody typing, which is good. Thank you. Right, okay, let's go on and have a look at the content, the breakdown. So, okay, this is going to go topic by topic. Again, these slides are designed so that you can share them with your students, right? Or you can share them with the teachers, or you can put them up as a poster in your room when you're doing it. Try not to use them as wallpaper. Okay, and what I mean by that is that if you have them around your room all year, then students will just ignore them. So if you're starting your topic on forces and motion, then put this up at that point, or put this up when you're doing your revision, right? And maybe it only stays up for a couple of weeks, but it just helps to focus them on what they need to do. Yeah, you will get these slides, so you can use them. When we look at this, we don't test the textbook. And that I want to make that as a really, really strong thing. We don't ever test the textbook. We test the specification. Everything on the specification can be tested at some point. Okay. But when you're doing this topic, there are an awful lot of formulae. So we're going to expect a lot of calculations. We're going to expect graphs, and we're going to expect practicals, right? The higher mark questions will often be the ones which are momentum, or what we call a linked multi-stage calculation. So the answer to part A becomes part of the information of data for part B, right? And that sort of question is what we call a linked multi-stage calculation. And they are often the questions which are targeted at the higher grades. Should they write their answers in standard form? Not always. I mean, yes, we will accept both, unless we actually say write your answer in standard form. So we will test standard form, we will test significant figures, we will test number of DP, probably a maximum of once per paper. If you've got students who are going to go on to IAL, then think about the good practice for IAL, right? And that would be better. If you've got a weaker student, and it's easy for them to write it as 0.005, then they will actually, it's easier for them. We will mark that. The next query: if a student doesn't finish the calculation completely, will they get some of the marks? Yes, so long as we can follow it. So long as we can follow it, because if you can't follow it, you can't mark it. The normal way an examiner marks is to look at the answer on a calculation. Is the answer correct? If the answer is correct, they probably don't need to look at the method, because how else would they get the correct answer? The only time they need to look at the method is if it's a show that. If it's a show that, they'll need to actually answer those, need to look at the method. If the answer on the answer line is wrong or is missing, they will go looking for the answer and can't find it. Then they will start at the top and they will work through the mark scheme. Is there a substitution? Have they done that? Right. Okay, I'm reading some of these questions. If the mixing of units, right, let's do the first one, the bottom one first. If they don't show any steps in their calculation and it's a 4 mark, they will get 4 marks if their answer is right. This is what we call a bold calculation, as in nothing to support it. So it's bold, B-A-L-D. If they have got SI units mixed up, it's a more, look at the answer line. Unlike A level, we are only testing the units once or twice. So if the units on the answer line are, kilometers per second, right? Then have a look at that. If they don't write if their answer doesn't match our answer because they've not changed into SI units, And some of them do. For some reason, the grams and kilograms are the ones they want to interrupt, and they sort of do some odd things. If the units, if their answer doesn't match our written units, they will lose the evaluation mark. Okay, I think I'll come to that, but I'm aware of the fact I'm about a third of the way through, and I do want to give some examples further on. Okay, topic 2. Please expect them to be able to read and draw circuit diagrams, and make sure they don't confuse the electrostatics with magnets. And they do it the other way around, and they talk about electrostatics having poles and so on, magnets having equal charge, the same charge. This is a topic I actually feel that is helpful by coming back and doing it little bits and pieces. Right now, I've just spotted, excuse me, I'll go back. I spotted something here, and I'm not sure if that's correct. Well, it says electrostatics paper 2. I think that's only linear, and I haven't spotted it before now. So mentally cross that out, and before I, yeah, just cross it out in your head, because it should be only linear. I'm sorry, I didn't spot that one. Timeline for the unit completion is in our planning documents, if you want to. If you're doing it the first time, we'll have a look at the planning complete. There is a whole scheme of work for planning that you've got available. Units. This is in Appendix 8, so you've got all the symbols. The one we really don't like is the old one for resistor and the old one for the bulb or the lamp. Okay. Most of those, we're not as fussy about this because we don't often have them crossing. So where they do have a junction, it's good practice to put a dot, but we don't always see that. The one they do confuse and get wrong, and we will mark wrong, is if they draw a line through their resistor and turn it into a fuse. Right? So just be aware of that one. That's a common mistake. Right. Assessment focus in this case on the energy stores is to do, right, we will test all of this spec. We will test all of this. There's a lot of calculations again. But the biggest thing here is, yeah, thank you, Preeti. It is, yeah. Why are the topics in bold? I don't know why they put topics in bold on this. Topics in bold in the specification is because topics in bold are not taught to double award science. Right? On the linear, all double award science people do paper 1 biology, paper 1 chemistry, paper 1 physics. And that's why the bold content is only tested and examined in their paper 2. Here in modular, there are 90 marks for single award science, a single award physics, but the 60 of those marks are going to be in a separate paper for double award. So we've separated it out. Okay, please try, if possible, to use the Institute of Physics energy stores. It is genuinely easier. I was a bit hesitant when we first introduced it. but I'm old enough so that I can remember having different ways of teaching energy, going back from when I started teaching in the 70s. So if you can have a look at energy stores, it's not a Pearson product, but Physics Online have got some YouTube videos on energy stores, which are very helpful. We have some older. The problem is if you use an older symbol, you're going to get some examiners who don't understand them, because some of our examiners are in their 20s. Which of these will you not use on the symbols? Well, we don't often use. I'm going to. Looking at that first column, I think we'd use most of those. Looking at the second column, we don't often use the heater. We do use the thermistor, the LDR, the diode, and the LED, the lamp. We don't use the loudspeaker, microphone, electric bell. We often don't show grounding or earthing. We don't use the motor. We don't use a generator very much, but we do use the fuse. So if you can, stick to these, please. Try not to use the old zigzaggy ones for the few and so on. Right, let's go back to point to say about energy resources, advantages and disadvantages. Cost is, no, we're highly unlikely to use some of those other symbols. So, and if we do, we will probably use the word motor, and we use the word generator and so on. So I wouldn't even bother. I just use the ones I mentioned, which, sorry, keep going back on this, is all of this column and numbers 2, 3, 4, 5, 6, and the very bottom one. So all of the other ones, all of this gaggle about loudspeaker, microphone, bell, earth, motor, generator, and heater, we probably won't use. And you're making your student learn something they're not going to use. Right. Solid liquids and gases. This is a section that we actually expect them to do. So we've got the density, we've got the pressure, we've got pressure difference. We've also got specific heat capacity and the calculations. Again, quite a lot of formula, so expect calculations as well. What we haven't got, right? We've got particle arrangements in solid, liquid, and gases, but we haven't got the thing about particle movement, right? And when you do it, please stick to physics, right? There's loads in the waves. Waves is such a big topic. I really would teach this in 2 or 3 chunks. I certainly would teach them. I'd teach them separately. There's an enormous section of this. And having said that, a lot of the students can actually do, for example, EM spectrum, they can virtually teach themselves at them. You don't need you to teach them this. You could give them a homework and they could actually find the order of the EM spectrum. They could find a use, they could find a risk. They don't need direct teaching, but some of this will, right? Some of the optics and so on. FET from Colorado is very useful because they've got some very nice in the refraction and ray diagrams and so on that you can use. Sometimes it's really difficult to do optics practicals if you're in a hot climate and you then have to turn the you then have to put the blinds down and get it even hotter inside. It's not a nice situation, but there are simulations you can do. Should students know Charles law? No, it's not in our specification, right? This is what's in our specification. If you want to teach Charles law, you can do so, but it isn't actually in the specification. What is more important is this idea of Kelvin. There was a very interesting question on the modular course, modular exam this year, where they had to do some data and extend it to try and find the Kelvin temperature, find out what was absolute zero, and they couldn't do it. They wanted to quote it rather than do it. So random motion, pressure on container walls, please, please, please try to use physics terms. Can we not have successful collisions? Successful collisions come up in chemistry. Nothing to do with physics. As far as we're concerned, it's a collision. That's it. An impact. We're not bothered. We don't need to know. We can treat them as tiny little balls and let them do anything, right? So keep it to physics terms. The number of every year when I'm leading a team, I would say that virtually every examiner grumbles about the fact that people use chemistry terms. Okay, so Charles law is not there. Right, electromagnetism is a topic which I really think you've got magnetism, electromagnetism, and induction. Don't teach them consecutively because they inevitably get electromagnetism and induction totally and utterly confused. Right? So put them in different orders. I mean, magnetism, they shouldn't need much teaching of this because they've probably done it in year 7 or year 8. So you don't need to reteach it again. But this one is, and this, they just get the two confused. I don't know. The radioactivity, again, talk to your chemistry department because they're going to do some of this atomic structure. Do you need to do this again? If they've done it, right? Probably not. Practical investigation, I'm going to give you the name of another company. There is an English company called Focus e-learning, one word, Focus e-learning, and this has it's a website which will give you I think it gives you 2 weeks of a trial, but normally costs trying to remember, it's about £100 a year for the whole school, and it has simulations in biology, chemistry, and physics that are suitable from year 7 to year 13. Right. Anton, I have yes. I'm not sure what different formula and definitions. We don't teach the Edexcel textbook. We teach the specification. That's it. If it's in the specification, then that's fine. Right. What we do insist on is that, for example, you do not use a capital C to mean current, that you use a capital I to mean current. And there's sort of standard definitions in that sense. So yes, you can have other definitions apart from what's in the Pearson textbook, right? So we're not going to ever teach. I do not have a textbook available when I'm writing questions. I just write questions. We don't even check it, right? With the atomic physics, the second part of the atomic physics, will you try and make sure that, again, concentrate that we're not going to get chemistry and biology terms, because they talk about daughter nuclei and they talk about cells. and it gets very confused. So just try and avoid or tell your students to avoid these. Right, that one, the next one. Right. In some students find this absolutely fascinating. And this whole thing about stellar evolution and cosmology, they will almost suck it up like a sponge. Make sure that you check their concepts correctly. Make sure you check their calculations. This is particularly where they need to use standard form, because they're going to have some very big and some very small numbers, right? We were horrified in the summer. There, on one of the papers, there was it was multiple. It wasn't a multiple choice. It was a closed question where they gave four orbits, and the one that they kept getting wrong was the one for the sun and the Earth. They could get the other orbits right, but they kept going the wrong one for that one, and we just did not understand it. So, differences in orbit speeds. Talk about the solar system, and we're not going to ask them the order of the solar system. We're not going to say which is the planet closest to the sun or which is the planet furthest away from the sun. It's the general concepts that we're more interested in. Okay. Right. In the specification, these are the physics formulae that you've got. These are the ones that will they, won't they? Last summer they actually had another booklet, so I think that's going to stay. I've asked about it, and I haven't been given a final answer. Maybe this is something you could ask Jonathan Wong. But I do think that the idea of providing you the relationships it should be there. To me, it's just clutter if you're asking them, because there's so many questions, there's so many formulae, for example, about work done and energy and so on, that the skill is picking them out, which is the right equation out of this list. Right, we are coming up to about 20 past, and I just feel like I mean, I was really grateful. Do they have any particular topics about measurements? Avoiding errors, finding accuracy, considering. Yeah, well, what is consistent in in the exam is that, for example, we ask about improving an experiment, and we'll ask about improving the accuracy, and we want common sense answers, really. That, you know, if they could use a more rather than using an ammeter, they could use a milliammeter, right? There is nothing specific in nothing in the specification apart from the fact that they're meant to do the practical work, and hence this sort of thing is what you should get from the practical activities. Now, on the Pearson website, there are a couple of really good books, free downloads, about core practical, and they've got one for the modular as well. There was one produced, okay, it's quite old now, 2017, but it's now still available, and it's still got some good useful information about teaching and so on. We are not as motion, simulations-based learning and learning tools like peer learning and team learning with formative assessment. Yeah, I would agree with you. I'm actually helpful for that. That's a really useful way of doing it. When we start teaching students in year 10, often we start with topic 1. And in the first week, we're going to revise speed equals distance over time. And a lot of students go, I did that in year 7. I did that in year 8. So sometimes going in and making the activities far more active and make it that sounds ridiculous, doesn't it? So making it a practical rather than to do a revision rather than making them give notes, so that they could, for example, look at a falling object. And that takes them into the idea of speed and time, and it introduces the idea about acceleration and the idea of forces and so on. So you can introduce your topic with an activity. The falling object could be cupcake. If you have American cupcakes, those little cases, the paper cases, they fall beautifully down the stairs. What's the key to get student prep up to the mark? Little and often. Little and often, I think, is the idea. And I am a very firm advocate of going into using mini whiteboards, where on the screen and the students come in, there are maybe 2 or 3 questions. Some of them are revisions, some of them are for you to find out what they know or don't know about the next topic. And they write their answers on the mini board, on the mini whiteboard, which is about this size. And when they've got their answer ready, they do, they have their answers written down and they hold it there. And then you can see who's ready, and when they're ready, they can show you the answer, and you as a teacher can see who has or has not got the answer. Can I recommend some good books for mechanics? In the Pearson Edexcel library. The answer to that is really no, because it's probably about, it's well over 10 years since I actually taught in a school. Topic-based past paper practice, good practice, yes, very much so. Use the exam wizard and make sure that when you're doing it, you actually are assessing all 3 assessment objectives. Okay, I'm going to have a quick look at these assessment objectives, and then we might have a short break. So assessment objectives are the way, I said we do not examine the textbook. What we do is we try and make sure that 40% of our exam is about the recall and knowledge of physics. Another 40% is about application of physics, and 20% is experimental skills, which could include analysis, evaluation of data, evaluation of methods, which is where talking about accuracy and which measuring instruments comes in, right? And that's what we test, right? We test all our papers. Every single paper has got to be balanced like this. The marks at IAL are very similar, right? We split A02 into 2 sections at A level, the market percentages. So if you only ever give a class test which has things like, what are the units of pressure? What is the equation for? And so on. You are actually only testing 40% of what we test. Because there's going to be 40% where we are doing calculations, we're going to give them graphs, we'll expect them to be able to do lines of best fit, all sorts of things. We'll expect them to, for example, there was a question a few years ago where we had refraction, and we actually applied it to the automatic sensor on a car, which moves the windscreen wipers when there's some moisture on the car windscreen, and was an application. There was an application this summer with a camper van that people went along, and they had solar panels on the top. So that was a useful way of doing it. So when you write your exam papers, make sure they're balanced, right? So yes, use Exam Wizard. Don't just use GCSE. You can use the linear, right? There's nothing to stop them. If you haven't got a question that you like on this, and you found a question on the website and it's from AQA, use AQA. If it's from the Cambridge, use Cambridge. Physics is physics, but try and make your exam papers balanced the way we do. Right? Why do we do it? We do it because we want comparability between papers. That's our basic rule of doing it. So this is AO1, state Newton's law, define current voltage resistance, recall the units, label the EM spectrum, state the function of a fuse. So these are often questions which are fairly easy to do. Not always. Some of them can be demanding, but they are recall. They are something that if you picked up a physics textbook, you could find the answer to it in a physics textbook, right? You wouldn't necessarily find the answer to a camper van in a physics textbook. You might have to Google it because it's an application, right? So AO1 is often targeted at lower ability, and medium demand, so grades 1 to 6. There will be some which are targeted at higher grades, but mostly they are targeted at lower grades. Right, so these are some of the questions. Right, well, I will point out one of the things we do in Pearson is to have space to write equations which hasn't got any lines, space to do calculations which hasn't got any lines. When we have a simple one which like give, state, we tend to often give them just one line to write on. We also give them the full width of the page to write the answers on. And here, when we've got heating lamps, give 2 similar properties of visible light waves and infrared. 2 marks. We've given them a structure, 1, 2, and we've given them 2 lines for each. Right? Yeah. Will students who write extra be penalised? No, but you'll irritate your examiner. There's no point. You're not going to get any more marks. If you go out of the space, there is a risk that it won't be seen. It depends on where it is. If it's at the bottom of the page, it very much is a risk that it's going to be seen. So when I was marking this might have been, this first section, part B part 1 and B part 2, might be marked by totally different examiners. So if you've got the first line, will, if it goes down the side, it won't be seen, because the first section might go to one examiner and the second section might go to another examiner. If you genuinely run out of space, then you actually need to say continued on page such and such, and then the examiners will be able to pass it up to a team leader who will be able to have a look at it. I found that this year I'm doing some remarks, where people wanted me to check their marking and so on. And I found one student who had consistently written on all the spares, on all the white space in the paper. And when I remarked it, he actually added an extra 10 marks, but nobody had seen it. Because he hadn't said continued on page such and such, continued on page such and such. Why don't we see very old papers? Oh, because they're all in Exam Wizard. The Pearson website goes back to 2017 for linear. And I think that's probably, I mean, you're looking at it, that's nearly 8 years. And two sets of papers a year, that's a lot. Any option in Pearson Edexcel allowed for generating question papers? Yeah, well, yes, this is what we call Exam Wizard. Right? Exam Wizard is an option where you can actually go on and have a look and find and make yourself an exam paper from this. Right, and you can select it. I'm no longer in a school, and because I'm no longer in a school, when I show you the screen, I can only show you the screen that somebody else gave me, which is from geography, I think. But yes, you can search it quite easily. Again, if you haven't got access, it's through your exam manager or your exam officer, and they can then use it from there. Veronica, do you use it as well? Because you use Exam Plus, Results Plus? Sorry about that. My colleague printed. Yeah, okay, good. It is easy to use. As I say, my technician used it for me, which made sure I was able to do it. I had an exam paper that I didn't know what was coming up. And when I did revision, they knew I didn't know what was coming up. It's quite useful. I make it 25 to 11 my time. I've been going for an hour and a half. So I'm going to answer my phone in a few minutes. I'm going to give you, shall we have I don't want it too long. Yeah, let's go a 10-minute break. Yeah. And Anton, so I will come back here at 11 my time, 11:45. I will just answer Anton's question, and then I'll turn my sound off. If they write down a definition, can they use the units? If they have standard symbols, yes. Not the units, but the symbols. If they have V equals IR, that's fine. If they say volts equals amps times ohms, no. Does that make a difference? Right, see you back in 10 minutes. I'm going to try and do the previous slide again. AO2 is the application. Students sometimes find this very hard. We've got, it's because it's not a textbook material. If you have the command word with things like suggest, explain, and evaluate, then they've got to have a look at and do some thinking. So if they can do the easier AO1 questions in record time, then it gives them some thinking time that they can use on this. Students often say, well, you didn't teach us about that. No, but we talked about energy stores, we talked about transfers. They've got to think about the situation and do it again. Right, these are examples that we have. And again, this is designed so that you can put it up in your classroom, in your laboratory. Keep it for a short time. Don't keep it up for a long time. And make sure when you write your exam papers that you include all of these. So how do you teach it? You teach it by modeling it, by giving them some structured practice. So don't give them a 4 or a 6 mark question which requires them to do and explain. Give them a question which is a 2 mark. And the first mark you can always think of as being state and explain. We're not allowed to use 2. Question, if the student provides more information which isn't asked in the question and not relevant, will it lead to cut marks? Not usually. We mark positively, we mark what's right, we mark what's on our mark scheme. And unless it's wrong physics, we tend to ignore the rest. There are occasions where we're looking at it and we're not going to mark it anyway. These are typical questions which are AO2, right? Suggest why a lawnmower has 2 switches instead of only 1 switch. This one is a question. I mean, the sort of the calculations come into AO2, and mostly students are okay with calculations. But in this case, describe how the force applied on ball A compares with the force applied on ball B during the collision, right? So there's application of Newton's laws again. Explain why a piece of iron experiences a force towards it. You can add to the diagram. So there's one command word there, but there's also what we call scaffolding, something given in the equation, in the question, which should enable students to access it more easily. AO3 is our experimental skills. They are data collection, experimental design, how to make judgments, how to make evaluations. We have some differences between us and biology and chemistry, in that frequently in physics, there's only 1 or 2 things to control. And hence the biology and chemistry sections where they use things like, they call them corms, or are things which we don't often use. We prefer them to actually think about the practical and ask and make some judgments. So these are all AO3. It's not just practical skills in the sense of writing a practical, writing a method, what are the controls. These are analyze, right? Evaluate the effectiveness, suggest improvements, explain why the data supports the hypothesis, interpret a diagram. So these are actually sometimes higher level skills, not just recall. So typical questions. Yes, we do sometimes ask you about the dependent, independent, and controlled variables, and that could come up. There was one where I think it was, I don't know if it was last year or the year before, how could a student accurately measure the height h? And they needed to say a data line from where they were measuring from and the measuring instruments and so on. Sometimes a question will have AO2 and AO1 mixed in. So if we have a solar cell could be used as a power source, they suggest it would work if the solar cell is connected directly to the lamp and the light from the lamp is used to produce output power to the solar cell, why it wouldn't work, and they're giving them hints. So these are, sometimes they are quite tough questions. So again, practice, practice, and more practice. Okay. Right. Let's get them right one. Okay. Multiple choice. It could be anything, a multiple choice. Short answer questions. We have describe, suggest, explain. Clear, concise responses. You do not need to write in full sentences. You do not need to write the question out again. We are not targeting quality written communication. If they want to write their answer in bullet points, we are very happy about that. So I'm trying to read this. Is it appropriate to use very old past papers? Can be. it shouldn't affect the student's score. What we should do is, does that question you want to use match one of our specifications? Does it match a content? If it does, use it, right? Longer questions, we can only have 1 6 marker on these papers for longer response. We can have some 4 and 5, but there's only 1, and we will never go above 6 marks. Right? Never ever go above 6 marks. Okay. We do have some planning. We have maths. Right. So when you're doing your homework, when you're doing your class tests, just keep varying it. Do not keep to what is the unit of. Give the equation for, right? Give them a thing about, how could they improve this practical? What is wrong with this graph? And so on. So keep giving them different styles of questions. If they're not prepared for the different styles of questions, you are doing those students a disservice. Okay. How many multiple choice? Maximum of 8. They're not always easy. They can be pure recall, but they might be a calculation, right? They might be so you can train students to do well on multiple choice, because you can go in and say, right, which answer is totally wrong, and that's eliminate that answer. Which 2 answers do you think are correct, and then discuss. So you can do some training with multiple choice questions. I found them useful for diagnosis, to find out what my students do and don't know. But it's not just multiple choice. It could be what we call a closed response question, right? So these are closed response. So in this case, we've got a region. It was obviously from the HR diagram. And they got the 3 regions, and they gave the astronomical object, and it was one line to whatever it was on that HR diagram, right? So this one is again, which star is a white dwarf? Those regions were probably on the diagram. This one is a calculation, possibly, right? It's requiring a bit more things. So they're not all multiple choice. Some of them are what we call closed response questions, right? Accurate, credit-worthy points. So short answer is 1 to 3 marks, right? Correct scientific language. Encourage students to match the number of points to the number of marks. If it's 3 marks, we will tend to give them 6 lines. Some of our students can answer that almost in 3 words, because when you look at the mark scheme has got 3 very brief sentences or 3 very brief points. They don't have to write. We will not mark them down for bad spelling so long as we can understand it. If the spelling is fusion and fission confused, then we're fussy. If it's reflection, refraction, then we're fussy. But normally we are not bothered. Have they used the right letter, vowel? If I can read it, I can mark it. Right? These are open response. Describe the function, 2 marks. So there's only going to be enough there and enough there. That's it. Give the name of another object. These are open response. Give a harmful, right? And the reason they're called open responses, the students got to pick them out of their own brain. They're not picked from a list, which is what we close. So what is a control rod? What does it do? Okay. And again, they're on the spelling and terminology. Gravitational is down there, right? we'd accept this. If they put refraction, it's too close to both reflection and refraction, and we wouldn't give a mark. Our mark schemes are points based, so it's 1 mark per point, right? No full sentences, bullet points. Look at the mark allocation. If they're writing for 10 minutes and it's only worth 4 marks, then they're wasting their time, right? So that's back to this whole idea about if students write extra. So when we have a question such as these, right, a red giant star eventually becomes a white dwarf star, discuss the differences. My answer would be put a line down the middle, and around one side have red giant and the other side white dwarf, and then I would put my comments on either side. Similarly, 2 pieces of evidence that support the Big Bang Theory. Well, you've got to tell me what the Big Bang Theory is. And then give me 2 pieces, then state the 2 pieces of evidence. So there's, you've got 3 marks out of the 6 before you even start, so long as you actually structure it. So what is the Big Bang Theory and what are the 2 pieces of evidence? You know, cosmic microwave background radiation and redshift of galaxies, right? So if you state those first of all and then discuss, you can see how students can actually gain marks by learning how to answer the questions, right? This is where I talk about the again, the biology or the chemistry. Use something, they sometimes put a no in there, columns. It isn't a helpful suggestion. So if your students start structuring their answers using the biology or the chemistry, try to gently suggest that those are for biology and chemistry and they're not for physics. Right, we tend to have fewer variables. We have fewer controlled variables. We're more concerned with the range of our data and the quantity of data. We want to look about how do we analyze data? Is this going to be a linear graph? Is this going to, and so on. And we want them to be critical about which instruments they select for the measurement. So an ammeter is not necessarily the best thing. A milliammeter might be better, or a multimeter set on a sensitive scale, right? So try to avoid this if you can. And I actually, when I got this presentation last week to read through, this is something I actually contacted the chief examiner on linear and the chair of sciences for modular, and that was the strong message coming through that they didn't really want you to use that. The chief examiner was rather blunt about his comment. Okay, so what do we do instead in physics, right? We want them to think, right? Might be an idea to start having them a list of questions. Which equation applies? Which quantities, usually 2, which quantities can be measured? With what? How? How often? How long? How are we best organizing the data? How do we prove the accuracy? Now, the Pearson have it is the core science practical book, which is free, does do a lot of this, but there is also a lab book if you want to buy it from Pearson, which I think is very well structured, right? So this is, consider these questions. So when we have a look at this, which was a question, describe a suitable method to find the specific heat capacity of concrete, right? They would have been this list of equations, this list of questions would have been useful. Which equation, which quantities, with what, how often, how best to organize data. So which equation applies? It's there, MP5. Which quantities should be measured? You've got mass, you've got time. right? With what? On a balance, with a stop clock, right? How? Keep taking the temperature out of the heater. How often? Again, it's probably there somewhere. How best to organize the data? Look at this. Plot a graph. Find the gradient. Use gradient equals, because that's a rearrangement of that equation. How to improve the accuracy? Repeat and average. So asking these sort of questions when you've got this as a question for the students to answer enables you to actually generate the mark scheme that we had. Now, I will point out, in our mark scheme, we will always give a mark. 1 mark is shown as with a semicolon, right? This column in the middle, right, allows you to, gives the extra information that the examiner needs, right? So temperature change, allow the idea of a specified temperature change, e.g. measure the temperature change for 10 degrees, accept the idea of measuring temperature change. So, right, accept the use of a joule meter. So this is our information, but our mark scheme is here. Right, are students allowed to use bullet points or numbered with steps when answering 4 or 5 mark theory questions? Yes, is the answer. Please do. Right, is there any deduction in marking if the steps are not in sequence? No. Now, this is unlike some of the questions at IAL where they have a question with indicative content and they've got a couple of marks for sequencing. Not at GCSE. That's a high level skill that we're not actually testing yet, right? So please, bullet points. Look at this. None of these are actually written in full sentences, right? None of these are in full sentences. Now, the use of brackets here on MP10, the brackets around the whole experiment means I don't need to see the words whole experiment. I don't need to see those here at that point. Okay. Right, this is another one. A student pours water into each bottle. It was small bottles and set in front of a heater. Describe a method the student could investigate how the color of the bottle affects the amount of infrared radiation absorbed by the bottle. You may draw a diagram. Well, if they don't draw the diagram and labels, then they're missing it, you know. Which equation applies? It doesn't necessarily apply in this case. Which quantities should be measured? And they're giving you about the measurement and equal distances. With what, how often, repeating, improving accuracy, which is calculating a mean. And in this particular case, there was some safety, right? So that question block could actually be used to help structure. Sometimes students only write answers in 1 or 2 or a few words. Yeah, it is totally acceptable. We do not need to write full sentences. If they write something like volume of water is kept the same in each bottle, right? Then they're getting MP1 rather than writing out. We must keep the same volume of water in each bottle, full stop. If they just put volume of water equals constant, distance from heater, and they could do that in the diagram, right? Same starting temperature. We're looking for the ideas. We're not marking. Volume the same. Yes, I would like volume water the same, but it's the only thing that we've got here because they're told water in the section above the stem of the question. So the volume is going to be referring to the water, and that's fine. All right, mark positively. Mark positively. So Command words we've talked about. It is essential they know them. If they get describe and confused, they do often confuse them. Describe is a verbal picture. A transformer has a soft iron core, which is often laminated. It has 2 coils of wire. On the primary side, there are, on the secondary side, can you see it's a picture? It's a verbal picture. If we have something like explain, right, how does a transformer work, right? Then you say things like, an AC current is placed in the primary coils and so on. So then you have then the secondary coils pick up an induced current. It's different. If you misinterpret the command word, you can fail to get the marks because you're actually doing something that, if somebody says explain and you do a describe, you're not going to get many marks. Repeating the stem of the question loses marks. If some child writes the first part of the sentence wrong, the second part of the same sentence correct. If they don't contradict each other, we ignore what's incorrect. Right? We only mark what's right. We ignore what's right. We don't mark down unless it's a contradiction. The best absorber of heat radiation is black, but shiny white surfaces are also good absorbers. It's a direct contradiction. So we would lose them, they'd lose the marks for that. Can they draw for describe? Yes. Should students explain every step scientifically? No. No, because going back to that question about the concrete, yes, there are only 5 marks, right? So it's a method. The method is find the temperature change. They need to find the temperature change. So they could actually just say if they find the temperature change, if they say we will find the initial temperature and the final temperature and subtract them, that's okay. When doing a calculation using the parameters, do the students need to show the equation they're using before doing the substitution? Not necessarily, but it is good practicing. Do their drawings score marks? Yes. I'm going to back to let me see which one. Allow marks from the suitable diagram. If they write it in that order, they get all 5 marks. Right? If they write it in that order, they will get the marks. I am not bothered about the order in which they do it. I sit there with a pen. Presumably you're talking about this one. So they found the mass, they found the time, they plot a graph of temperature against time, they find the gradient, and they repeat the whole experiment. They have got sufficient of the marking points to get 5, right? They don't need to use the formula, right? If they don't use the formula, it doesn't matter. If they've got MP, you find the gradient of the temperature time graph, right? So we mark what is correct. And the fact that they haven't done the other ones is irrelevant to us, right? Yeah. You are much harsher and much meaner with your students than I am, right? Okay, so some of your the command words can involve a calculation without actually saying calculate. So show that, evaluate, deduce. Some of these are very, very open-ended, right? These are in the not sure which appendix it is, but they are in the appendix. So calculate means calculate, right? Comment on probably might require a calculation. Complete might require a calculation because you might have to complete it with a mean. Deduce, again, might require a calculation. Describe usually doesn't. Determine usually often requires. There must be a quantitative thing. Discuss again might have calculations. Estimate does. Evaluate does. Give a reason, probably not. Justify does. Plot could be a calculation. Oh, incidentally, when I went to Bangladesh and somebody was talking to somebody and they didn't realize what a suitable scale was. If a student ever writes a scale in 3s or 15s or 30s or any multiple of 3, any multiple of 7, it's not a suitable scale and they will lose the scale mark. Right. Biologists can be more fussy about whether we put the dependent or the independent on the X and the Y. In physics, we're not usually that fussy, as long as it's labeled. So can you see what I mean? There's large quantities of these command words which can mean calculate. This is quite useful, that some words actually require more information. Explain, evaluate, discuss, state as an easier word. So the cognitive demand increases with some of our commands. Right, so sample assessment material. You have got the specification. You've got the information about the exam and the double award. They're on the website and they're here to download, right? The specification like this, and there is sample assessment material as well. This summer's, last June's exams are on the website, but they're locked. That means if the student goes onto the website, they can't get them. The person who can get them is your exam officer if they give you, and they might give you the key to unlock them. This enables you to say, right, I have got secure exam papers that the students haven't seen, but I can use for a mock or I can use for revision practices. Right. So there's loads of course materials on these. Is it worthwhile putting it? I'm not sure about how long you can get it, but you certainly can get the slides. Leon might be able to tell you more about whether or not you can get download it. I think you can. I'm not sure exactly how long it's available for. Yeah, yes, you can get the slides. Okay, that's good. Thank you, Leon. You can access the recordings later today by visiting the same Zoom link. Good. Okay. With the command words, what I tend to do and what I did before I stopped teaching in the classroom was to put up 3 or 4 command words a week and have them as command words of the week. Which was quite useful. The other thing you can do is to take a chunk of them, and get them to match the command with the description of the command. It's something that I wouldn't necessarily spend a full lesson doing, but it's worthwhile. Again, if you're coming in a settling down exercise, ask them, what's the difference between explain and describe? And as a settling down exercise. Okay. Do you get an e-certificate? I think you do. You're welcome. I'm doing 2 more this week. I'm doing linear tomorrow and I'm doing improving assessment. I'm doing one which concentrates more on marking on Thursday. Right, the core practicals. We've embedded them in the thing. That's quite useful. This is the core practicals in paper 1. Okay, so look at the first one, investigate the motion of everyday objects. You could, for example, ask people to take their phones and their stopwatch on their phone and get somebody to walk around the room, get them to, and you could measure the distance they travel, and you could use somebody walking around the room, speeding up, slowing down, to generate graphs. Or you could do it with toy cars, or you could do it with tennis balls. Some of these are, I think, for example, the insulated materials charged with friction. I think FET has got a nice one of these. Investigating density is one that you should be found helpful. So I mention again, the company that I used a lot was Focus eLearning, and I believe it's £100 for everyone every student and every teacher's access for a year. And that they have some really good simulations which go all the way up to year 13 and go all the way down to year 7. Right. And you can do quite a lot of these in there. There are 1, 2, 3, 4, 5, 6, 7. This one, describe how current varies with voltage, really sneaks in. It's not got investigate there, it's got an investigate at the end there. So we do expect practical on that one. Right. Then on paper 2, you've got those practicals. Again, using this one is really, really hard. If you haven't got radioactive sources. So have a look for online simulations. Again, with the oscilloscope, not many people have got lots and lots of useful oscilloscopes. Oscilloscope is, I think the Institute of Physics have got an oscilloscope, but have a Google for virtual oscilloscope. There are about 4 online that you can use. And again, I find those quite useful because the kids don't mind doing a homework. If you say, have a look and see about this oscilloscope, I'm going to give you a test on how it works at the end. And they actually enjoy playing with an oscilloscope online. Right. We don't have a practical endorsement. We are testing it mixed in with the rest of it. The list and the apparatus guide are aligned with the UK home GCSEs, and our questions can be everywhere. So if it's how do you do a standard specific heat capacity, because that's already, they should expect to know how to do that. They wouldn't know it for concrete, but they should know it for a metal block. That can be A1 because that's recall. All of these things are tested. Right. Analyzing, using technical language, evaluating methods. Okay. So this is some of the sort of questions. We've already mentioned this before, but this is a nice simple answer. Draw a table of values. It's good practice for A level, making sure that they know that they should be putting these in columns, and that they maybe the units should go in the top, and they should either present these alphabetically, or they should present these in order of the power, and that will be some of the marks. How to use the oscilloscope to measure time period, again something that you can do. Receive through my I'm thinking about that. I will check. I will check and see if I can put it in and send it to Leon. If I send some links to Leon after the meeting is finished, then I should be able to carry on from that. Improving accuracy. So, okay, right. There's a whole range of things in there. I really want to get on to. I couldn't imagine getting through this amount of information while teaching physics at the same time. But if you've got this list of experiments here, we should maybe be doing some of these in year 7 or 8. And we could actually be testing some of these in year 7 or 8, which will give you really good foundation for working in year 9, 10, and 11. Right. So, but I would say put your practicals into your schemes of work. It's useful if you can to actually teach practicals explicitly. So when you are introducing a practical, say, what are we going to teach? What are we going to measure? Why are we measuring that? How are we going to do that? So we actually need to explicitly teach this. We can't assume that they're going to pick it up like a sponge. Okay. And we'll get some reflection on the results. Even if they get awful results, you can actually learn a lot from it. Why were your results so bad? What happened? What did you do wrong? What could you improve on? This is the information that we've actually got free on the website. Right? This one, it goes back to 2017, and this one is the core practical guide for Modular, and it's first issued this year or last year, I think. They give you information on how to do it, and they give they show you then how this links into past papers, right? How we would test this information. Okay. I think most of people have been answering questions as they go along, and I am aware I've got less than half an hour left, or about half an hour left, and I want to talk about math skills. Right, maths. 40%, up to 40%, 30 to 40% of the marks for maths. And it's not all doing the calculations. Some of it is drawing a gradient. Some of it is plotting data. Some of it is evaluating. So the problem with a lot of maths is who teaches it? If you need to do rearrangement of equations before it is being taught by your maths department, you are likely to have problems. Let them do the teaching first. Find out when they are working. When are you doing rearrangement of equations, and actually get them to do that first, and then teach it in yours, and make sure you do it the same way around. I was taught something called cross multiply, which apparently now is a no-no. Shouldn't be doing cross multiply, right? If you are looking at the skills, they're down in the specification again, but don't just keep them for homework. Put them in the middle of the lesson. We don't often use percentage and ratios, but we do averages, and we do estimates, and we should use standard form a lot. I'm looking at your question. If the student manipulates the equation first and then substitute the value in, it's fine. But that's where we find most students make mistakes. So if they can't rearrange and they get the rearrangement wrong, that's where we stop marking. So if they do the substitution first, they will get a mark for that, so long as it's dimensionally correct substitution. So I'm not going to penalise them if they put a mass in kilograms when the question's given to them in grams. And I'm not going to penalise them even if they put a time in hours, because it's a dimensionally correct substitution. If they do if they then go on to rearrange incorrectly, then they've at least got that 1 mark, right? So it's old-fashioned practice is often very good. Write the equation, write down a list of what the symbols, and write the values for those symbols, and then substitute them into the equation, do your rearrangement, and do your answer. And it's old-fashioned, but it's good practice, and it certainly helps when you get to IAL, because they are more. What would get 2 or 3 marks at GCSE will maybe only get 1 or 2 marks at IAL. They're harsher, if you like, with their marking. They're stricter with their marking. So keep plugging the math skills, right? Stick them in wherever you can. You know, every lesson should have some maths in it. I'd like to have you can do them in Key Stage 3. Make sure that they're used to the idea that when you have physics, you're going to have some maths. Use quick starters. Exit tickets. Exit tickets are, you put a question up, and as they go out the door, they've got to show you the answer. It might be a short calculation. V equals IR. What is a voltage when the current is this and the resistance is this, and they've got to do the calculation. Give them some data handling tasks, and make it an ongoing part of the lesson that they're always doing, right? This is the list. Now look at the biology. All right, and you'll see how many of these are missed out in biology. Look at the chemistry, and you'll see how many are left out in the chemistry. And then look at the physics, and we missed 2. We do not need to do principles of sampling, and we do not need to know the terms mode and median. Right? They probably will. Whereas the biology has got 1, 2, 3, 4, 5, 6, 7 bits they don't know. Chemistry 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't that interesting? So yeah, those are the skills that we should test. Calculations appear everywhere. State the formula, calculate the resistance. Right, and that one is quite interesting because it's got you know, if you look at it on when you find it on Exam Wizard, calculate the mass of the land. Here, can you see where we're bringing standard form in? This is going to be at the end of the paper, because we don't want to put that question at the beginning of the paper, because it's going to make some of our students feel incredibly upset. If they found that as question 1, they would go, oh, well, if this is question 1, what's the rest of it like? But we are there testing their ability, right? So all of these are maths. Comes in an awful lot of these. Right, now, we wrote this originally in 2017. It's now been rewritten. It's 68 pages. It is really, really good. I'm not just saying it because I work for Pearson. I actually find that it is very, very helpful. It does the biology and the chemistry as well as the physics. I find it's useful to go to your maths department and say, is this how you teach this? Is this how you teach that? and make sure that you're not teaching a method which is different from the one that they use in the maths department, because you don't want to add anything extra onto it. So, do you think any student is going to want 68 pages? No. So what we've done, which is on the website, is we have got 1, 2, 3, 4, 5, 6, 7, 8 of these. And each of these is usually no more than, I think the longest is about 4 sides. So this one is standard form. And it talks about standard form. And what I liked it for is the fact it shows you how to use your calculator. And it's a very clear way of using the calculator. So we've got these short PDFs. We talk about decimals. If a student leaves that answer as a fraction, they will not get that answer mark. That is very definitely a no-no. You've got to have it as a decimal. So again, your able students are probably fine with decimals, but your able students, judging by what we've seen in the past few years, don't know how to do, don't know that they can apply what they learned in maths and gradients into their physics, and they did badly on it. Percentages we use, but then biology uses as well. So we've got rounding, sampling. Sampling is not physics really, but significant figures, standard form, graphs, tables. These are the sort of thing, again, you can put up around your lab or around your room, and you can also hand out to students. I would suggest, I think these are accessible to the students, but I would, if you have a website for your students, I would put these in there and then they can find them and they've got the information. That is so helpful of how to do the calculations on your calculator. Because it's the biggest problem. They just don't know. They don't know how to divide on a calculator when you have a number like 1 times 10 to the minus 15. They don't know how to do it. And we end up with what we call power of 10 errors. Right, lots of things to do. Is it acceptable to write them equations in triangles? Please no. Why? Why make them learn another thing? Make them learn the equation V equals IR, and then make them learn the skill of how to rearrange it. The problem with the triangle equation is you say, well, is what happens when you've then got V squared equals U squared plus 2AS. And they don't know, they want to use a triangle again. Whereas you teach them the skill of how to rearrange an equation, how to move things across the equation and so on, it's far better for them. So we refer to them as silly, dumb triangles. Because it's speed equals distance over time. So silly, dumb triangles. Try to persuade your teachers in your lower school, in your lower classes, not to use them either. I think sometimes teachers who are not specialists in physics will use them. Not always very helpful. Any other suggestions about using maths? Well, the thing about this is I can't see who is typing, so I'm going to assume, and I can move on. Planning. I did say I would come back to planning. There is a scheme of work on the website. It is designed to support the different models, the 1 year, the 2 year, the modular, the linear. It is in Word, so you can customize it. You can chop and change it. I will say, please do so. If you know, for example, that there is a bank holiday, a festival in your country, and it's bang smack in the middle of a time, then make sure that you're not hitting a difficult topic. I mean, for example, quite a lot of the world is Muslim. Do you think it's a good idea to target a topic such as electromagnetic induction in the middle of Ramadan as a query? Because your students will not have eaten or drunk for hours, and you're asking them to do something quite conceptually difficult, and I don't think my brain works terribly well. Not until I've had 1 or 2 cups of coffee in the morning. So when you think about customizable, don't just think about the timetable. Think about activities that are going to impact your students outside of your classroom, right? Think about what they're going to occur. I know that in the UK, a lot of students get extremely giddy just the week before Christmas, and they get very hyperactive. So that's a possibility of looking at. Again, I would tend to do group work activity when they're all hyper, and I would ask them maybe to do me a poster on the life cycle of a high mass star, which they can actually do a lot of the work themselves. They can teach themselves. It's something new they like, and it keeps them going without it being everyone sat in the rows in the classroom and so on. Coming to Anton's question, is it possible to use additional mathematical equations if we need to support a question? Yes, but you shouldn't need to. I think we've got there are sometimes alternative routes to get to an answer, but you shouldn't need to use additional mathematical equations. But if you do, just make sure you can follow it. Okay, let's have a look at our next one indeed. The textbook still matches the specification. It's still got the active line. I would tend to use the scheme of work as being my foundation, right? And then building opportunities to put in my different things. Retrieval in this case means testing. Do they know the information? Practicals and assessment. Use the textbook, use active learn if you have it. If you haven't learned it, use the internet. Right? There's a lot of information out there on the internet that you can use. Sometimes the internet's very helpful for starter activities as well. The course planner, I will show it to you in a moment. There is also on the website a mapping document which shows how the content with AQA and Cambridge International overlap, right? And the scheme of work itself has got actually tells you which specification points and which lesson plans. So let's have a look. This is where it is. And you say there's a course planner, there's a guide, mapping documents. They're all down here on this website, and it says Physics Modular, easily accessible. Okay. This is the sort of thing that you will get in the scheme of work. Right. So if you're absolutely brand new to it, it helps. So they give you the section, they give you the specification points, they suggest some activities, they suggest some demonstrations, class practicals, they talk about the skills, and they link it to the textbook. Now, as I say, I find the textbook as a resource for the students. It's not necessarily a resource for me. This physics lab book I find helpful. You've got something called the Teaching Hub, which is new. It's quite expensive, but I believe it's very, very useful, very helpful in there as well. And there's all sorts of things. So they're giving you the basic bones of the structure that you can work from. And there's a couple of more examples. I didn't spot that one of the, sorry, my apologies. I'm sorry. I did not spot that this one was all biology. I'm going to make a note of that for myself. Slide 108 is biology. Is the lab book available on the website? No, it's available. Well, no, because you don't normally buy your textbooks. It's a textbook. I think I bought mine from Amazon, right? But I think if you're buying a number of them, you probably better buying it through Pearson in your own country, and you can actually negotiate a reasonable amount of discount if you can. Right? These are all popping up. Sorry, this is Institute of Physics is a good website to have a look at. FET is a good website to have a look at as well. Okay. Isn't it nice when they do all this work for me? Yeah. The content's the same as linear. The resources are designed for linear, are suitable for modular, right? Right. So chop and change. The Getting Started guide, which is free on the website, has got the course, has got the formula, has got the assessment information, has got any key changes, right? And it's there. It's not too bad. 1.3 megabytes. Again, I'm sorry I didn't spot all of these. I did try and edit this biology out. So that one is 109. And when I do this one for linear tomorrow, I make sure it's not the same. It isn't it is actually not prescriptive. It's a guide, right? It's a guide. It's nothing that we can actually definitely do. Will I do the chemistry training? No, I'm not going to do chemistry. I will just do the physics. But Anton, you will get something very similar for the chemistry, right? The chemistry will be very similar. I actually made sure I tried to put the physics content in, right? I will be doing the linear physics, and then I'm going to be doing another physics one on which concentrates more on marking, right? And a little bit on our mark schemes though. Okay, when we have a mark scheme, we have got semicolons to give us our things. We don't care whether our answers are going to be in the same order as we've got them written down. We will just mark them where we see them. We have things like ignore. If they say that gamma has a high range, it's not enough to mean as gamma is highly penetrating. Gamma is harmful. We will allow a given harmful effect. So if they say gamma causes cancer, then that will get a mark. If we have allow gamma can't penetrate concrete, right, then that's the same as the concrete is absorbing the radiation, right? So when we're marking, we use this column very much as well. And there's our standard answer, and there's our, if you like, expansion of the answer. Every mark with a with a semicolon means it's one available mark, right? Now, in this case, this one is about how is fission different from fusion, and here we will have some reject marks. So this is all to do with nuclei, and it's nothing to do with atoms or particles or molecules, because it's not sufficient at that point. Reasonable alternative for a split. If we say breaks up, then that will be an acceptable alternative to splitting of the nucleus, right? If we have something like the nucleus fuses, although we haven't put it down there, but it's an acceptable alternative for combining. Okay. So left-hand column is the question number, middle column is the answer written by the principal examiner. These are expected. We don't need to write answers exactly. Key vocabulary and clarity. Every marking point has a semicolon. Additional guidance is in the right hand. We accept it as accept, allow, condone. We really don't like condone. Condone it's often written down that way, but we reserve the right to reject it in years to come. Ignore, treat the word as if it's not there. Just imagine putting your thumb over the top. And do not allow and reject. Do not we only reject it for that one mark. So if marked out of 4 and we have against marking point 3, we have reject. We only take marking point 3 off. We don't reject the whole answer, right? So it's just that one mark. Okay. If we have something that's underlined, we have to see that word, right? We must see it. Nothing else will do. Bold words require a very close synonym. Smooth brackets like this are optional, but the meaning must be present. Curly brackets with this sort of thing around the word brackets here. We often have A/B/C. It means one of those words or phrases must be present, right? If the idea is clear, we will award the mark. If the vocabulary is used sufficiently accurately, we can award the mark, right? Right? We are never giving you a levels-based question. So if it's 4 marks or 6 marks, we will have at least 6 individual correct points, and it might be more. We don't give marks for spelling or punctuation or grammar. We don't have to give an essay. We don't have to have, copying out the stem of the question. If they want to write it in bullet points, fine. It's much easier. Please try and persuade your students to write in something larger than 2 or 3 millimeters high. We always have some, and then it becomes so difficult. I mark on a large screen, but I'm lucky. I haven't got small children, and I haven't got, I'm not working all the time on a laptop. But you can imagine having to constantly expand your laptop screen in order to see whether somebody is writing, whether it is increase or decrease. And sometimes it's very difficult to discern the difference between the handwriting. So if I can't get the handwriting right, then it's not going to be helpful. So I'm almost at the end. I have got about 10 minutes. I have got some corporate slides, but while I'm going through those corporate slides, is there anything else that you think we should do differently? Right? So this will obviously be repeated at the beginning of next year, and there will be, if I know what's missing, I can put it in, right? If it's helped, please say so. If there's anything that you want to share with your colleagues, I will try and send to Leon a couple of Word documents. Would give you some links, things like the virtual oscilloscope, which are useful, and so on. That might be helpful. So if that's okay, while you're putting some ideas down, I'm just going to go through the last few minutes doing these corporate slides. This is a recurrence of what you can find on the website, the materials, the support, right? There is all of this information there, right? The specification, the past papers. Remember I said that some of them are locked. They will be locked for as long as we can, because they're locked for a year, 1 year. And after that, they are open, and then students can access them. But your exam officer will be able to access these for you. Some of the support documents that we've mentioned, the forms, the admin, and there's quite a lot on teaching and learning materials. Right? I mentioned Results Plus. This is a sort of thing that you can do. You can do an analysis. This one is it's quite new to me. It wasn't around when I did it. Mock analysis service, print past papers, assign papers to students for mock mark entry. Right? You can compare yours against people around the world. You can set up groups, so you can put your different teachers in different groups. It's a very powerful and free tool, right? I don't know what this is in this Results Plus. Yeah, student takes exams, exam papers are scanned, we mark it online, and then we share it afterwards. Now, this is the one I didn't have an opportunity to change because I haven't gotten access to it. This one was for geography. So you can select the qualification, you can select a year if you want to, you can select a series, you can select a unit, and you can actually access and export the PDF. You will get, when you export it, you will get the paper, you'll get the question marks, and you'll get the exam, the principal examiner's comments. If you haven't seen any of the principal examiner's comments, again, they are locked for a while, but they are really, really good. They take some time to actually show you clips from past papers and see and tell you what students got wrong and where they did well. Very, very helpful. Okay. Access to scripts is really, again, I have marked something like 120 exam papers in the last couple of weeks for people who wanted it remarking, and nowadays I will say that most people will find they'll find a mark, because you can see what they've done right, and you can got the mark scheme, you can test, and you will say, well, okay, you are 4 marks away from this, but from that margin, is it worthwhile? And the answer is yes or no, according to the mark scheme, according to when you can see the access to scripts. Helpful, really helpful. I wish I'd had it when I was around. There's a textbook, which I'm sure you're aware of. It's not a bad book. If you've got a textbook that you've bought for another exam board and you want to, you don't have to change immediately. I will send that message, because physics is physics. What this does is to match our specification So you might have to do extra bits and pieces if you use another textbook. But that's fine. This is our new person in international sciences. You've got an email for him. You've got a phone number for him. Write your query. If he doesn't know the answer, he will know who does know the answer. When we get a query like this, we are required to answer it within a certain time scale, which is good. I think we're almost at the point we can. Oh, I've got 4 minutes. Right. Any other comments you want to make? You can fill into the in the chat. I will sort out this and send it to Leon. So I think if you come in back into the Zoom meeting in an hour or so, you should have them. You should be able to access these other documents. You get the PowerPoint by going into the Zoom meeting again. Once you've left it, you should be able to, and it's in resources, which is, I don't know if yours is in a different place to mine. I think it's under more. No, I'm not sure. Okay, there's the download link from Leon. Leon, do you know about the certificate? Okay. Right, I think you've got the links there as well. Thank you for being very helpful. I know it's very difficult with a Zoom meeting, especially one where it's more me giving you information and not getting the information back. But it has been quite a responsive session with you. Thank you so much for your participation. I am really grateful for that. It makes it easier for me, and I hope if you're doing the chemistry or the environmental science later in the week, that they are useful too. Keep an eye on what else is available. If you're interested in the modular, I can't off the top of my head remember, but I'm doing a feedback about the modular later, might be October. They had to move some of my dates, so that you keep an eye on what is available. Okay, thank you very much.